Hello, geometry. This is 1.3. We get to have two main formulas today that we will use throughout the year, the midpoint and distance formulas. Now, these are definitely formulas just like we have a formula for the area of things and the volumes of things. But more importantly is understanding the idea behind what these actually do and what you want to do. And a lot of times you won't have to know the formula. You'll just know, oh, this is what I'm looking for. Okay? So I'm going to look at this graph that we have here on Exploration 1, page 12. We have a line AB where points A and B are as shown here. Okay, so A is up here at 3, 4. B is down here at -5, -2. So, and we have a line going between those two, like that. Okay. Explain how to bisect. Okay. So bisect, that's kind of the word we're focusing on today for right now. Bisect, the prefix bi, like a bicycle, means two sections. So how to cut it into two equal sections. So how would you go about, think about how would you go about this line segment, cutting it up so that you had two equal sections that were the same length. Okay. So what we needed is like, okay, where's the middle of this? That's what we need here. We need to know the middle. If I can find the middle, then I can find how much it is. So kind of glancing at this, we can say, oh, my guess would be probably around right through here. Now, what happens a lot of times is we end up drawing right triangles. So from this point, I'm going to go over, straight over horizontal, and this one I'm going to go down like this. Okay? You notice I made a right triangle. So if I break this into the horizontal and vertical components, let's count. Let's just say, how long is this? So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units long and 1, 2, 3, 4, 5, 6 units tall. So if I want the halfway point, or the middle, I'm going to have to go 4, 1, 2, 3, 4, and then up 3, 1, 2, 3, let's see where those intersect. 1, 2, 3, 4, right there, and right there. So there is what we refer to as the middle. Okay, and we're going to have a special name for that, and that's just called the midpoint, because it's the middle. Okay, it's the midpoint, it's the middle. So this length right here and this length right here would be the same because that is the middle. Okay, so use the results to find the midpoint M. So that'd be the midpoint M of line AB. Okay. Now remember, finding the length, Pythagorean theorem, just a quick review with that, a squared plus b squared equals c squared. When you have a right triangle, A and B are the legs, called the legs. C is called the hypotenuse. So when you have a right triangle, this is the hypotenuse, this is a leg, this is a leg. Doesn't matter which one is which. Okay, so hypotenuse is the longest side, the one that's longest. So 6 and 8 would be our legs, so 6 squared plus 8 squared equals c squared. That's 36 plus 64 equals c squared. So c squared equals 100, square root both sides, c is 10, which means the length from A to C equals 10. So notice I didn't put any symbol on top of that, I just said the length from A to C is 10. A to M would equal 5, and M to B would equal 5 as well. This should be A to B, sorry. A to B would equal 10. A to B equals 10. Okay, so let's look at these definitions, what we have going on. Let's jump to page 14. So we have two things here. We have a midpoint, and the definitions are down here. Midpoint of a segment is the point that divides the segment into two congruent segments. Same length. Two congruent segments, same length. So M is the midpoint of AB, has to be between it. So AM is congruent to MB. Notice the segments are congruent, the lengths are equal. So if this is 5 inches, this has to be 5 inches. Okay. A segment bisector is a point, ray, line, or line segment, or plane. So 1, 2, 3, 4, 5. There's 5 things it can be. A segment bisector. that intersects the segment at its midpoint. A midpoint or segment bisector bisects the segment. So think cuts in half. That word bisects is going to show up a lot. So whenever something bisects something else, it cuts it in half. Okay, so a midpoint or a segment bisector bisects the segment. So this is some terminology that's going to come up to play in your problems too, the questions that you have. Line CD is a segment bisector of segment AB. So here's segment AB. Line CD is a segment bisector. It's bisecting a segment. We'll also have angle bisectors later on. So AM is congruent to MB, AM to MB, and AM is equal to MB. Okay? Notice you can't have a line bisect. You can't bisect a line because a line doesn't have a length. It's infinite. It goes on forever. Here's your formulas. The midpoint formula, it's the average of the x and the average of the y's. Okay. So what they did here is kind of similar to what we had. We had 2 points. x1 and x2 are the coordinates. Remember, those are coordinates of A and B, the x coordinates of A and B. So if they want the middle, they take x1 plus x2 divided by 2. That's the average of them. For the y's, they take y1 plus y2 and divide by 2. So let's say we have points at -3, 8, and 4, -6. And they want us to find the midpoint. That's x1, y1, x2, y2. Okay, same sort of setup that we did for slope in Algebra 1. So your x midpoint would be x1 plus x2 divided by 2. So that's the average of the x values, -3 plus 4 divided by 2, which is 1/2. Okay. Your y would be y1 plus y2 divided by 2, the average of the y's. So 8 plus -6 over 2 would be 2 over 2, which equals 1. So your midpoint m would be 1/2 and 1. Okay, 1/2 and 1. The distance formula, this is just a fancy Pythagorean theorem. It's just a fancy Pythagorean theorem. So we have 2 points. They want the length of this. You see the triangle? We already drew that earlier. The length that we counted here is just going to be x2 minus x1, the absolute value, the distance rule that we had from the previous lesson. Absolute value of y2 minus y1. Okay? This is the distance for these two. So it's x2 minus x1 squared. There's the a squared plus b squared. This is kind of like a squared plus b squared equals c squared. Now they already did the square root step right like that. Okay, so there's the Pythagorean theorem. C is the square root of a squared plus b squared. Make sure you're adding them before you do anything else. Let's take those points. -3, 8, 4, -6, x1, y1, x2, y2. So the length is going to be the square root. Let's follow this. x2 minus x1. So subtract the x's. So subtract the answer, x's, square it. Subtract the y's, square it. Subtract the x's, square it. Subtract the y's, square it. So 4 minus a -3 squared. Careful how you did that. Notice that I subtract them, but I'm subtracting a negative. So x2 minus x1 plus y2, -6 minus 8 squared. Okay, so subtract them. 4 minus -3, 7 squared, plus -14 squared. Okay, see the parentheses, the negative there? That is important. Keep that in parentheses, especially if it's a negative. So I get the square root of 49 plus 196. So add them together, before you square root. Add them together before you square root. So 49 plus 196, that should be 245. And then we're going to take the square root of 245. 7 root 5 would be your fancy answer, or about 15.65. Okay? So we're dealing with inches. So we'll see some more Pythagorean theorem, distance formula sort of work here in some of our examples. Okay, that's just midpoint. Maybe we should do another one of those at some point. All right, so identify the segment bisector of AB, then find the length from AB. That is the length. So here, the segment bisector is point M. It's a point in this case. AB would equal 13 times 2, which is 26, because if that's 13, that's 13. If that's the middle, those two are going to be equal. Okay. Segment bisector here is a ray MC. Notice endpoint and direction. The length from A to B, if that's 8, that's 8, has to be 16. Segment bisector here is line L. AB equals 52. If that's 26, that has to be 26. Get to use a little algebra here. Okay, identify the segment bisector, then find E to F. So here, your segment bisector is ray MT. Okay, M, endpoint, in the direction, MT. Find E to F. So we know that 6x has to equal 2x plus 4. 6x has to equal 2x plus 4. So I'm going to solve for x, minus 2x minus 2x. 4x equals 4, so x equals 1. Then I go back up and plug it in. 6 times 1 equals 6. So that's this side. 2 times 1 plus 4 is also 6. So we know EF has to equal 12. Okay? So I set the two parts equal to each other, found the value of x, plugged it into one side, and then doubled that answer. Segment bisector here is line M, lowercase m. X plus 15 equals 7x minus 3, minus the x plus the 3 over here, so 18 equals 6x, so x equals 3. That means that is 18. 18 times 2 is 36. So EF is 36. Again, a lot of times on these videos, I'll try to explain it as I go along, but I don't leave a lot of think time with that. So go ahead and pause it. Try the next one on your own. Try it before I get there. See if you can get it right. Okay. So point M is the middle. 3x minus 4 equals 5x minus 12. So minus the 3x that side plus the 12 to this side. So 8 equals 2x. X equals 4. Put that up here. That's 12 minus 4. That gives us 8. That's 20 minus 12. That also gives us 8. So I did it on both sides to kind of make sure that's the same answer. So EF would be 16 on that one. In exercises 7 through 9, the endpoints of PQ are given. Find the coordinates of the midpoint. Midpoint, remember, we're using the averages. Okay. So your midpoint, your x is going to be negative 4 plus 0 divided by 2. So this is x1, y1, x2, y2. So x plus x divided by 2. So that would be negative 2. Y is going to be y plus y divided by 2. So 3 plus 5 divided by 2 is 8 over 2. That would be 4. So your midpoint M is going to be at the location 2 to 4. So x here, negative 2 plus 10 divided by 2. So that's 8 divided by 2. That's 4. Your y is going to be 7 plus negative 3 divided by 2. So that's 4 over 2, which is 2. So your midpoint M would be 4, 2. Here, P, 3x is going to be 3 plus 9 divided by 2. That's 12 over 2, which is 6. your y is going to be negative 15 plus negative 3 divided by 2, so that's negative 18 over 2, which is negative 9. So your midpoint would be 6, negative 9. Okay, this one's going to go the other direction a little bit. They say find the midpoint. The midpoint M and one endpoint of JK are given. Find the coordinates of the other endpoint. Okay? So this is the midpoint. And remember, the x of our midpoint, I'm going to put xm, equals x1 plus x2 divided by 2. So what we're looking for here is we're looking for this one. So this is x1, and this is xn. That's our midpoint. So 1 equals 7 plus x2 divided by 2. So multiply the 2 over. 2 equals 7 plus x2, and minus the 7. So x2 equals negative 5. Okay, let's go do that with our y's. This is y1. This is the midpoint for y. So it kind of just changed these for y. So negative 2 equals y1 plus y2 divided by 2. So negative 2 equals 2 plus y2 divided by 2. Multiply the 2 over. Negative 4 equals 2 plus y2. Subtract your 2, you get y2 equals negative 6. So the other point, this is J. Remember, K was the other point. We're looking for point K. That's what we want. Point K would be at negative 5, negative 6. Okay, now let me get some graph paper. A graph can be very helpful for using this as well. So if I have J at 7, 2, 1, 2, 3, 4, 5, 6, 7, 1, 2. Here's J. And M is at 1, negative 2. Here's N. Okay, that segment has to be going in this direction. So it has to be down here. K has to be here. Because remember, we have segment JK, and we have midpoint M. So M has to be between J and K. So you can use slope and just rise over run to count this off as well. So you go, if I go down 1, 2, 3, 4, if I go down 4, I have to go over 1, 2, 3, 4, 5, 6. 6 to the left. So follow the same pattern that we have here. Down 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. K should be right there. Let's check that. That is 1, 2, 3, 4, 5. Notice I'm going from 0, 0 now. Going from the origin. 1, 2, 3, 4, 5. So negative 5. 1, 2, 3, 4, 5, 6. Negative 6. So K on my graph is at negative 5, negative 6. Is that what we had? That's what we had. K is negative 5, negative 6. So you kind of always, if you start with J and you're working your way here, do that same pattern as you go to K. So 7, how do I go from 7 to 1? Well, I subtracted 6. So what's 1 minus 6? Negative 5. How do I go from 2 to negative 2? Well, I subtract 4. So negative 2 minus 4 gives me negative 6. Okay, so let's go through all those steps here again. So this is my midpoint, so 0 equals 5 plus x2 divided by 2. So that means x2 has to equal negative 5 because you need a 0. So 5 plus negative 5 gives us 0. So the y's, now I'm looking at my y's, negative 1 equals negative 2 plus y2 divided by 2. Multiply that over, so negative 2 equals negative 2 plus y2. Add the 2 over, and you get 0. So y2 equals 0. So negative 5, 0, that should be our k. If I check that, j is at 5, negative 2, 3, 4, 5, 2. M is at 0, negative 1. So there's your j, there's your m. We're going this direction. So it looks like it's up 1, 1, 2, 3, 4, 5. Up 1, 1, 2, 3, 4, 5. Probably not drawn very well. It should be right there. 2, 3, 4. That is negative 5, 0. That's where it's at. Okay. Okay, you start getting the fractions in. That's where these rules kind of help us to play. So let's look at the x's first. Negative 9 halves equals 2 plus x2 divided by 2. We multiply the 2 over. Negative 9 halves times 2 is going to be negative 9 equals 2 plus x2. So negative 11 equals x2. And for the y's, we have a 7 and a 16. So 7 equals 16 plus y2 divided by 2. So 14 equals 16 plus y2. Negative 2 equals y2. So negative 11, negative 2. That'd be point K. All right, let's do one more example with the Pythagorean theorem. Draw that one out. So let's just make up some numbers here. So let's say we have negative 2, 4. That can be point A, and point B is going to be 5, negative 3. 5, negative 3. And we want to find AB. So that'd be the length from A to B. So AB is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So subtract your x's. 5 minus a minus 2, then we'll square it. So subtract first, then square. So 5 minus a minus 2 is 7. 7 squared. Hey, got another 49. Subtract your y's. Negative 3 minus 4 squared. Oh, got another negative 7. Okay, that's going to be negative 7 squared. Whenever you get a negative in here and you square it, make sure your answer is positive. It will never be a negative 49. If I would do that, I'd get a 0, and my length can't be 0 unless they're the same point, which they obviously aren't. Okay, so these two numbers will always be positive. If they're not, you did something wrong. Those two numbers will always be positive. Add them together, so square root of 98, and we want that as a decimal right now. The square root of 98 is about 9.9, almost 10. Square root of 100 would be 10. Okay, so we'll see you. Good luck. Go Bluebirds.